Hey, Jam, I don't know what it was like for you, but when I was growing up, we had film cameras and you had to like snap a button and roll the film over and then snap another and roll it over. And once you'd taken all the pictures you wanted, you had to carefully take it out and put it in a little tube and take it to get developed somewhere.
Yes.
And then they did mystery science that magically turned it into a picture.
Yes.
Well, today we're going to be inspecting the mystery and we're going to unmystery it.
It's so eerie how similar our childhoods were in that specific area. Like when you're saying that, I was like, me too. What the heck?
When do you think you switched to a digital camera?
I remember one of my uncles having the first digital camera I ever saw. He was a very techie dude. And we took a picture with it outside of my grandmother's house. And that picture still existed for a long time. Maybe still does in someone's album somewhere. And that digital camera picture is awful. I mean, it is so bad.
But it was instant.
It was, yes. And we went and printed it out on my grandmother's printer. So that was the thing that we were like, oh, we just took this picture.
Yeah.
And here it is. So
it was a big deal.
Yep.
My first digital camera that I saw is my mom wanted one for Christmas. And so we went to all these different places and looked at all of them. And I just remember being like bored that I had to go and stay around with my dad, you know?
Yeah.
So that's what I remember.
Yeah.
Well, are you ready to learn about the science behind filming?
I'm so ready. I know I'm not the only one, but I'm one of the people who's been asking for this.
Oh, yeah. We're going to talk about all those people, too.
Okay, cool. All right.
Let's get into it.
Let's do it.
Let's roll into it. Roll a film. There's a lot of people who didn't get that joke. Okay. Hey, I'm Melissa.
I'm Jam.
And I'm a chemist.
And I'm not.
And welcome to Chemistry for Your Life,
the podcast that helps you understand the chemistry of your everyday life.
Okay, I have a lot of shout outs I'm going to do at the top here.
Or this might be more like your everyday life 20 years ago.
Right.
You know?
Just the thing that pops into your mind every once in a while. They're like, how did that work?
Yeah.
So, yeah, that's true. I didn't even think about it. It's not really everyday life anymore. It's like a niche community now. Okay, well, I'll say that first. Well, a lot of people have Instax cameras, and we're going to talk about those probably next week, though.
Okay. Yeah, there's like, in my lay people's knowledge, I know that it seems like there's enough where it should have its own episode. That's what I was hoping would happen.
Yeah.
So, nice.
Okay, so let's say that first we want to welcome and dedicate this episode to Justine, our newest community member.
Nice.
Welcome, Justine. It's so nice to have you here.
Yes, thank you for joining our super cool chem community of patrons on Patreon. You're joining a group of people that are some of our favorites in the world. We love all our listeners, but we love to especially thank our community because they make the podcast possible for everyone else.
Yeah.
So thanks for joining, and we're grateful for you and glad to have the chance to get to know you.
And we hope you like your ad-free episodes and your bonus episode. All right. So then second, I want to send a special acknowledgement to Brian, who has been patiently waiting and consistently asking for, but not in a way that's annoying, just like every once in a while, for film photography episodes.
Nice.
And I went and looked at the first time he asked, and it was August of 2022.
Wow. Okay.
I was like, yikes. It's the 5-year anniversary of that question being asked.
Wait, 2022?
Sorry, not 2022, 2020.
Okay.
August of 2020.
Got it. Okay. Got it.
Sorry, I saw the 2 2s, I guess. August of 2020. So it's been 5 years.
Okay. Wow.
And so here's my 5-year anniversary gift as an answer, finally.
Nice.
And this is the first time he asked. He said, I was just listening to the alcohols episode and heard Jam's quick mention of film scanning. And I'd love to hear about analog photography and also his photography. It's a passion of mine and something I volunteer my free time towards with a local nonprofit called the Eugene Darkroom Group.
Wow.
But although I have a basic understanding of the chemical process, I'm still a bit perplexed on it. And so when I reached out to tell him that we were starting this series, he told me that he does still want to hear about your film journey and how it's been going.
Nice. I have to dust off my memories. I mean, I have done some recent stuff, but most of my like really diving into it was before. But so Eugene Darkroom Group, you said?
Mm-hmm.
Are you in Eugene, Oregon?
Maybe, I don't know.
Wow, cool.
Okay, so then I also recently, like in the last month, so she had to wait a lot less time, wanted to shout out Dawn, who asked on our website, how are your pictures developed using chemicals before camera phones? And how do Polaroids work? They develop right in front of you. And so we'll answer one this week and the other in 2 weeks in our next episode. Just the first question today. And then, of course, I also want to shout out Jam because he's also been asking for this behind the scenes this whole time, too.
Yeah, I don't think I've ever, maybe once or twice, have I like texted an idea to Melissa and been like, put some on the list or something. But usually it's in our recording sessions where I'm like, by the way, is this on the list anywhere?
Yeah.
Or it's during an episode. Will we talk in this episode or next episode or a different episode about how they fit all of those like development chemicals into our phones? It's like, how do they get them in there?
There was a thing about how digital pictures work, so I could probably do an episode on that too. But I'm like, it is chemistry, I guess, because it's light.
Right. It just gets, it's getting so into like electronics where you're like, well, this is all under the umbrella of like electricity is communicating things.
Yeah.
And these particular kinds of things.
And it wasn't a chemistry, American Chemical Society thing. So I was like, nice. Okay, well, they're trying to relate it to chemistry.
Yeah.
So this could even be a 3-parter. But right now it's only 2. Okay. So, and that actually brings me to my last thing is the reason why it was hard to do this is every time I went to research this, it was hard to find good, clear resources. They would give you like the basics, but wouldn't go deeper. And now it's summer and I have a little bit more time. So I spent more time than I normally would really researching. And I found a nice paper from the 1970s by a pair of researchers at University of USF. It's Southern Florida, I think, South Florida.
Mm-hmm.
And they really went in depth on color photography. And in the process, answered a lot of questions that I had that I was frustrated by in all my other resources. And I was like, nice. I just had to go all the way back to the 70s.
Mm-hmm.
So I also wanted to shout out that paper as well.
That's interesting because it's something that I guess you wouldn't like disregard research that's that old normally, but you would hope for something more recent.
Right.
But why would someone need to do that now when it's only become less and less relevant?
Less and less relevant, but also they were doing a lot of researching at the time on like, okay, what is the whatever behind this? So when they got those basics down, then they're moving on to more advanced things. But the more advanced things were too advanced and people aren't really talking about film photography anymore.
Right.
You know, because of what you said. So, but there's a whole area of photochemistry and this goes into it. It's about lights. And photo, I think, comes from photon, which is light, you know? And I guess you're kind of graphing it onto the page. Okay, so, and I did kind of want to ask, what is your experiencing with developing film? Or what's your experience with film? What do you know about the chemicals, if anything?
I don't know very much. When I got to yearbook as a student, we had a darkroom, but we didn't use it by then already. It was like... They were holding on to analog for a while, but not out of a cool kind of thing, but out of like being at a school that didn't have a lot of money and that was set in its ways. But, and so I don't really know very much. I don't know. Like, I think I could, once you start saying the different sort of baths that they do, I bet I'll be like, oh yeah, I've heard of that. But it was never been explained really.
Okay.
And it may even have been like, oh, in a movie where they're in a dark room, they mention putting it into the silver bath or whatever. And stuff like that.
I mean,
where
silver.
That's like, I heard that, but no one explained it. You know what I mean? It's just the thing they said.
Yeah.
So, yeah.
Wow.
Developing,
okay, well, that's something.
I have not developed.
You haven't even
film.
in your radio, television, and film degree?
No. No, we didn't. I could see in like a film photography, because there's a photography program at UNT. I could see them doing that, but because we wouldn't shoot on film for any of our projects, and that'd be like a much bigger deal for whole reels, you know, a film for like a mag of film for a
movie
or short film would be a lot. So we didn't do that. and we did do some photography projects, but they were digital. So,
Okay.
Yeah.
Okay, great. So I'm just going to pretend then like you're a blank slate.
Yeah.
Okay, so I'll say film is a great name for it because the thing that we call film that we put into cameras to take pictures on, and maybe we should actually just say for people who have never seen a film camera, the way that they work is you get this canister of film that's like wrapped completely in paper basically, and you like no light can touch it, and you have to load it into the camera in a very specific way so that it's lined up just right and no light is touching it. And then once you get it into the camera, you can like pull a tab off or whatever in a way that it removes the coating, the covering, but is still protected from the light because it's in the camera. And then you close the camera, and then you have to do what we call winding it, where you like literally turn a knob, and that's moving the film over to be near the lens so that if the lens opens, which is what happens when you take a picture, light will hit it. And then the lens opens for a minute and then it closes back down, and then we wind it again so that it gets to the next spot where another picture can be taken and they're not laying on top of each other. Is that a good explanation?
Yeah, I think so.
Okay, great. So that's what film cameras are like. That is crazy that I had to explain that. And there is kind of like a revolution of them coming back, especially disposable cameras. And my sister-in-law bought some for her birthday weekend.
Nice.
And then she was like, everybody take pictures all weekend. And then she's like, I was going to get one for everybody, but they were way more expensive than I thought. So I got one for each couple.
That's so funny that they're expensive now.
Yeah.
That's crazy. Like, I know that the cost of like a roll of film has gone up, but the thing that's interesting is you can still find film cameras for very good money. Like,
interesting.
Because there were so many made for such a long time.
Yeah.
And everyone had one.
Yeah.
And now there's just a lot of them just still exist.
Yeah.
But way less people need them. So
yeah.
They're just on eBay and stuff. But rolls of film have gotten expensive too. But
so maybe it's because of that. I don't know.
Yeah.
So they were just more than she thought they were going to be, I think.
Yeah. Or there's probably just like the economy of scale thing.
Yeah.
You know, whoever is making these disposable film cameras just isn't making like millions of them like they once were or whatever. But
okay, so now let's get into the chemistry here behind it. So the film that then we load into the camera that takes the picture on it, it's essentially like a roll of plastic, probably something like acetate, some kind of polymer. If you want more on polymer, we have a whole episode of that, but basically some kind of base plastic that is essentially supporting the layers of chemicals, or layers of chemicals or thin films of chemicals, which I'm like, is that why they called it film? It's because we have films on it.
Mm-hmm.
And so for each of these layers, there are chemicals that are light sensitive, which means they will undergo a reaction that when given energy from light, so when exposed to light, they will absorb the energy from that light and it reacts. And that chemical reaction is the thing that creates the image that we'll see. So that's kind of like the bare basics. And probably what a lot of people could have guessed already is like, you have this paper, special paper, light gets on it, and then we have a picture.
Yeah.
Okay. So now that's the overview. Before we zoom in, I want to do like a traditional chemistry lesson, and then we'll go back.
Okay.
So the reaction that occurs that I just mentioned is actually a simple, not super simple, I guess, just classified as a redox reaction, which is redox is short for reduction and oxidation.
Mm-hmm.
We've talked about that before. What do you remember about that?
That redox would be if you're adding bonds to oxygen.
Yes, that is oxidation in a organic chemistry.
Uh-huh.
Then there's the other kind of redox that you talk about in general chemistry. They're doing the same basic things, but I kind of think about them slightly differently.
Okay. You are gaining electrons.
Mm-hmm.
But it's weird because you're becoming more negative, but you're adding more of something at the same time, right?
Yeah, that's reduction.
Okay.
Do people remember like oil rig?
Mhm.
Oxidation is losing electrons. Reduction is gaining electrons. So even though what's being reduced is the charge. So that's why we call it reduction.
Okay.
So perfect. Great. I'm so glad you remember that. So yeah, these reduction reactions is essentially when an element or a molecule loses electrons and another element will gain that electron. And so often we'll see that happening with salts. Okay. So a salt is a positively charged metal and a positively charged non-metal. So like table salt is one example, but there's lots of different kinds of salt. So table salt, NaCl, our metal that's positively charged is Na, sodium. And our non-metal that's negatively charged is a halide, a halogen, chlorine.
Okay.
That's just a name. Halogen is just the name we give all these elements that are in that row. The furthest to the right and one over from that is the row of halogens. And you have like chlorine, fluorine, bromine, should be iodine, but it's iodine. Those are all halogens.
Okay.
So with table salt, we have one of those halogens, chlorine, and it's negatively charged because it has one extra electron. And then they'll be attracted to each other and they make these very strong bonds that we call ionic bonds.
Okay.
Because when a molecule or an atom is positively or negatively charged, we call it an ion. So we have these ionic bonds that are super strong and they're easy to dissolve and disperse in solutions.
Okay.
So in the case of film, you mentioned silver, and we do have silver ions. We call it, it'll be silver halides. It can be silver bromides often. So silver is the positively charged metal that's missing an electron. And then any halogen could be there, but it's usually bromine. So it's in the same group as the chlorine, just one group, one down from chlorine. That is negatively charged. So it has one extra electron.
Okay.
So we have the silver that's positively charged because it's down an electron. The bromine that's negatively charged, it's up an electron. And we call these both ions and they'll be attracted to each other through this ionic bond.
Okay.
So if you have this silver gain an electron, we would call that a reduction. So if it goes from positively charged silver to just neutral solid silver, like silver metal that you would see, that's a reduction reaction.
Okay.
And in the case of silver bromides, they are sensitive to light. So if you shine light on them, what we think happens is that the electrons get excited. We've talked about this a few times, but essentially electrons have areas where they're likely to be. The center of each atom is positively charged, and it's surrounded by a negatively charged area where electrons are. And those electrons are attracted to that positive center. But if you give them energy, they're able to kind of pull away further. It's just like a kid. If you have a kid who's like tired and hasn't eaten in a while, they're going to be like clinging on to you. Like, I don't want to do that. And then you give them some food and a nap and they're like, and they're like trying to get away all the time and do whatever they want. That's sort of how electrons are. So if you have a silver bromide situation where this bromine has its extra electrons and it's in the dark, the bromine's holding on to its electrons. The silver has lost some, so it's positive, so it's near the bromine and they're fine. But if you give the bromine some light, then the electrons around bromine start to get excited and they can move further away from that center, that positive center, and they can get excited to the point where they're then able to transfer electrons back over to the silver, which is unusual for that to happen. But when it does happen, we get silver metal. So basically we just have a reduction reaction where the bromine gives its electron back, and then we have a neutral bromine and a neutral silver. Now, a question I had is, doesn't that make a bromine radical? Because it has then an unpaired electron. This is for people who are, deep in the chemistry. But if the reaction happened enough, I think those bromines would find each other and they are naturally a gas. So that's what I think happens, but I had a hard time confirming that.
Interesting.
Okay. So if we shine light on these electrons or on these salts, then the electron can get excited from the bromine and shift back over. And when the silver is reduced from the ion, where it's in its salty state, it then becomes solid silver metal.
Okay.
So that is the key to film photography. So we have these plastic sheets that have a thick gel that are also usually made of some kind of polymer, something like gelatin. It's a matrix is what we call it. You've possibly heard it called an emulsion, but it's not an emulsion. It's just like a name people gave it, but it's more like a bunch of silver bromide suspended in what we would call a matrix, but essentially just like the silver bromides are suspended in a thick-ish liquid, so they're not moving around. They're sort of like trapped in this matrix.
Okay.
And so you can spread them evenly over the whole film in a very thin layer.
Okay.
So your film is essentially a sheet of plastic just covered with silver bromide. And when you expose that to light, the light hits, the reaction occurs, and solid silver is formed.
Okay.
And solid silver is not see-through, but the salts, much like table salt, if you dissolve it in water, is pretty see-through.
Okay.
So when you have it in a film camera and it's all protected and no light has ever touched it, and then just for one moment you open it and close it back, you will get a perfect impression of all the light that has come through that film. And we're talking about just black and white for right now.
Right.
Because as the light comes through, it will hit in varying amounts depending on, how much light is on each thing. And will make either more of the salt react to turn to solid metal or less of the salt react to solid metal. So after that first initial shutter opens, light comes through, shutter closes, you essentially get a proportionate reaction of how much silver metal is formed based on how much light came in at every single area.
Got it.
What questions do you have for me right now?
I had already forgotten that we were just talking about black and white only, and then you reminded me about that, so it's perfect, because I was already about to ask which things is it sensitive to, like which on the color spectrum, basically, whatever.
Yeah.
But this is just sensitive to light, period. So it's just basically where there is light, it will have that reaction. Where there is dark or dimmer amount of whatever it's taking a picture of, it will have less of that reaction or almost none.
Exactly.
Got it. Okay.
Yeah.
So basically, across that whole frame, each little spot of that coating of the silver bromide liquid, right? It's like
well, I think by the time it's on the film, it's solid.
It's solid. Okay.
But the silver bromide suspension. So the silver bromide spread evenly across. I was trying to think of what's like that, a suspension that we see, but like bread sort of is like that, where the bubbles are evenly dispersed, but they're not really evenly dispersed,
Right,
so I can't think of a perfect example of that.
Yeah. Okay. Okay, that makes sense. I think I'm tracking.
Okay.
This helps that this whole area has been both a hobby of mine and a part of my professional life in a way too, where even though I didn't work with actual film as much professionally, it's like we would talk about some of the old technology of it in some of my classes and stuff. So this is, it's like I'm getting a layer deeper than I had before. But if I didn't have any of this, it might be a lot harder. If I was like completely green, but some of our listeners may be able to tell us that.
Well, and something for me that is a little bit weird is when I think about a camera and like, okay, it's the shutter's opening and then it's closing and it just let light in for that one moment. I'm like, but it's just letting all the light in that's in front of it. And then I had to think about it and think like, no, it's basically doing the same thing our eyes are doing, that the light is coming in and we're interpreting those colors of all the light. Light isn't just beaming straight into my eye. That would be terrible.
Right.
We're looking at light bouncing off of all the things around us. And that's what makes color happen, is light makes color happen. Right.
Right.
So that kind of helped me too, if that's a question that you have, that I was like, but wait a second.
Yeah.
Sometimes when you're researching things like this and you get really into it, suddenly you're like, I think everything I just read doesn't make sense at all.
Yeah. Or it's like you still have a very fundamental question that just like no one's trying to answer because
It's
they're
so
going
obvious
down a
to
different
them.
yeah.
Yeah.
But there's so many of the things that are still true about digital photography and videography that are there about like how fast is the shutter opening and how large or small is the aperture and how sensitive is the film to light at that moment, what they call the ISO. And that kind of stuff stayed as part of the like trifecta of things you have to get right when you're doing photography, even in digital photography. So that kind of stuff, like it's still gonna forever be bound to kind of the way it was started with film. Which makes sense because like if you're just gonna open the shutter and just leave it open, obviously it just has way more time to react. Yeah. And even a small amount of light in a dim area can make its way in. Yeah. So yeah. And just kind of gives all that suspension tons of time to react with something and then turn white, basically be like a lost frame. But
well, it's not turning white yet. At this point, it's just turning to solid metal.
Right. And
it's not letting any light through, so it kind of just looks black where there's too much light. It's not white; it's just dark.
Yeah.
So, you put your film in the camera, completely protected from light, and then again when you take it out, it's completely protected from light. But it does have these specks of silver metal all throughout the film now after it's been exposed to light. And the specks are so small that initially we actually can't see them. They would be considered a latent image is what we say. So it's just like one atom of silver, basically, right? One atom of silver metal in each area that the reaction took place.
Wow.
And so it's you can't really see anything at this point. And that is where developing comes in.
Okay.
So we then take this film that's been kept in the dark, so no more light's been exposed to it, and we put it into a chemical reducing agent instead of the light being the reducing agent. So the light making the bromine the reducing agent. But basically we put it in some kind of chemical bath that will give the silver the electrons it needs to turn to silver metal. And essentially that happens more easily where the metal already is. So that silver metal that was formed during the camera taking the picture acts as a catalyst or maybe even a nucleation site where because there's already one little grain of silver metal there, it helps more silver metal form faster.
Okay.
And so it basically just amplifies the latent image where there's like a bunch of little molecules of silver we can't see. We put it in that bath and each one of those grows to be bigger and bigger and bigger until we can see them.
Okay.
And so when they come out of that bath, then we have basically, it's not completely finished yet, but basically what we call negatives.
Right.
So we have a strip of film that has been exposed to light in a certain way where all of the things that were very bright white, lots of light, are completely opaque and dark because the more light, the more reaction, the more silver metal formed, the faster that development happened. So we were like, okay, now we have these pictures that are dark. They're the opposite of what we want. And if we bring them out into light, they'll keep reacting because they still have this silver bromide on them.
Right.
So then we have to put them in a second and oftentimes there's like these are really optimized for actual film that's sold. I'm giving the very basics, but a second phase or a second bath, which would be something that would dissolve the rest of the silver bromide.
Okay.
And that's usually called like fixing it or like stopping it. And so then after that, we have now taken our little tiny amount of silver metal that was formed with light in the camera. We've used an additional reducing agent, which means a chemical that can donate enough electrons to amplify that to where there's lots more silver metal so it's visible with our eye. But we can't go too long because then the whole thing will turn to silver metal.
Right.
So then we stop the silver metal reaction and we get rid of all the other silver bromide so that if we take it into light, it won't keep reacting.
Mm-hmm.
And now we've frozen only basically an amplified version of the silver metal that was formed in the initial picture
Mm-hmm.
into something that we can see with our eyes. And it mimics the pattern of light that was originally captured.
Right.
Where the areas that were very bright are very dark.
Mm-hmm.
And the areas that were very dark, they didn't have as much light, so they don't have very much silver metal now.
Right. Right.
And then we have to, that's the negative. And then we have to actually shine light through that
Mm-hmm.
onto something else so that the light shines through more in the areas that are darker, right? Yes.
Mm-hmm.
Yeah, because you get the exact opposite.
Right.
So then you can take that negative and basically do an inversion where all the areas that were really dark because there was more light there because the silver shined on it now, or the silver metal formed because light shined on it. Now, when you do the inverse, they become very light. And the areas that were very dark now have more light on them. Does that make sense?
Yes, it does. Wow.
How do you feel?
Like one of the first things I'm like, man, dude, it must have taken forever to figure this out. You know, like I know that some of the early photography was super different. It was like on a plate that they just coated. There was no developing because it was just like whatever they put on there would just react immediately.
Yeah.
And then they probably would do something to stop it. But
yeah,
it's like crazy how people figure this out.
And I do think this might be one where they figured things out more. Like they didn't know all the science behind it. They just knew like, oh, these things react with light. And so we can do the same.
Yeah.
I did read something that talked about the person who first discovered light, like making cameras, but I don't remember what it was now. I had to do a lot of research for this. And this part was pretty straightforward for me. But when we got into the color and the Polaroid, I was like, whoa. So that was a little bit pushed all the basics out of my brain.
Yeah. Man, very crazy.
Well, do you want to try to explain that process back to me so we can catch any misconceptions or have just one more chance to get it processed in our brain?
Yeah. So when we want to capture an image, in this case, in an analog way, we need to have something that is sensitive to light so that when we show it something, it will be affected in a predictable way. The light bouncing off other stuff will be captured onto it. So people found that silver bromide was sensitive to light enough where when you show it, expose it to light for just a brief moment, it will get excited. And is it during the state or is it coming back down that the silver and the bromine separate?
The electron on the bromine is the one that gets excited and it's sort of trapped in there, and in that trapped state is when it transfers. But I think the semantics of that are probably beyond the scope. I think the biggest thing that matters is when the light hits, it allows a somewhat unusual thing to happen, which is this salt, which is pretty stable. I mean, usually salts are pretty stable. It's like, boop, now I'm going to move over this electron.
Okay. And so it does that in the areas where, on the film, where there is more light hitting it.
Yep.
And makes these very, very, very small little atoms of silver metal that now are not, the bromine has left.
Yep.
And probably paired up with other bromine and evaporated away.
That's what I think.
Okay.
That is, though, like I could not get confirmation for that.
So at this point, it's just a lot silver atoms scattered across the face of this thing in a way that we wouldn't be able to see anything, but it is it is at a molecular level representing loosely what was happening in real life.
Yes.
And so from there, taking the film, keeping it from getting exposed to light again, into a bath of, is the bath also silver bromide?
No, it's a reducing agent. So one that's used a lot is, oh gosh, I just lost it from my brain. I don't want to say it. I read so many. I'll say it again. I'll look it up in my resource and tell you at the end. But it's like a chemical that's good at giving up electrons, but it's not necessarily. It's not more silver bromide.
Okay. So it's a reducing agent, but because of the areas of the film where there already are silver atoms, it will sort of help continue the reaction in that area with other silver bromide.
Yes, it basically facilitates the conversion of the silver that's positively charged into neutral silver metal.
Right. It helps.
It's like a catalyst.
A catalyst to help more of the silver, that's positive, be reduced to just a neutral silver.
Yeah. The silver metal does that.
Neutral silver hotel.
Exactly. Neutral silver hotel.
And so then that gets us more into the space of way more of these atoms where it needs to be the case are have become silver atoms that are neutral, where if you were to look at it, it would be dark, correct?
Yes.
Even though that's only because of it being lighter in real life.
It's because silver metal is solid and not see-through.
Right.
So anywhere you had more light, more reaction happened. Okay. So more silver metal was there.
Yes.
So we just amplify that. And so it gets covered with silver metal. And that cover with silver metal is it's like solid silver. So that's why.
So we've amplified it. And now we want to stop because it still has this catalyst on there that's helping things react, and we want to not keep doing that and just turn everything to silver. We don't want the whole thing to be silver. We want to actually see what we took a picture of. So then they put it through what was the second bath called? You said it's a fixer or a...
Yeah, it'll stop the, sometimes it's called a stop bath, but it basically stops, you want to stop the development, and then you also want to wash away all the leftover silver bromide. All silver
bromide is washed away, but silver neutral stays. Yep. It is solid. It is there. It's attached to the film, the cellulose or whatever.
Yeah.
And so from there, it's stopped, and now there's no more silver bromide, so it cannot react to light anymore. So we have a negative in that all of the very bright spots that we saw in real life are very dark spots on the film.
Right.
And from there, to get the picture we want to see, we can just flip that when we shine light through it, or if we were to scan it with a scanner, we would digitally invert it or whatever.
Yeah.
And then we could see whatever we took a picture of.
Yeah. If you imagine shining light through it onto like a white background, anywhere that the light is totally blocked, you know, you would have that be white. And then other places that the light shines through, the color could shine through, you know, or the dark, you know, it'll be the opposite. So I found the name of the oxidation reagent that they do. They'll do, it's called hydroquinone, which I don't know if that means anything necessarily to you, but they do that in the presence of a base. And so that will make the reaction go really well, especially right where there's that silver metal. And then as soon as they want to stop the development, they dip it in acid. And then from the acid, they'll put it in the final fixing step where the silver halides, usually silver bromides, just get removed.
Okay.
Interesting. Yeah. Isn't that crazy?
That's very crazy. It's so many steps. And then what's impressive to me and anyone who has worked with or just viewed like film photographs is how good it looks. It's like they've gotten it so good that it's not like, oh, that kind of looks like grandma or whatever. It's like, no, this is exactly what she looks like.
Yeah. and it's like mimicking our eyes,
Mhm.
basically. Which that's something that also kind of blew my mind when I would think about it is like the reason it works is because our eyes interpret color like in this certain way, and so our brains interpret it one way, and then we just put light on this thing, and then our brains interpret that thing the same way they interpret real life. It's just crazy.
Right. Yeah, it goes back to that whole deal of like, this thing isn't a color, it looks like this color.
Yeah.
It's like, it's all because of light hitting a thing and then the way our eyes interpret it.
Yeah.
But it isn't, I don't know.
It's kind of like, have you seen that thing where there's like, the person is in the mirror and they have the like towel in front of them?
Oh my gosh. Yes.
And everybody's like, how does that work? And you're like, it's not that the mirror can see, it's that the light is reflecting in a way that you can see.
Yes. You're part of this equation.
But it's hard to think about that. I can see how that would be hard to think about. I'm like, it kind of doesn't make sense. And that happens to me a lot when I'm doing camera stuff or light and color through, where I'm like, wait, but why does that happen?
Yeah, that's so interesting.
Okay, well, I think you did a great job explaining it back to me. Normally we wrap up with some categories after you explain it back to me. And I was going to ask if you have one film picture from your childhood that you just love. And then I also wondered if you wanted to share about your film journey. But I know that we have limited recording space. So if you want to, do you think we have time for you to share about that?
I think so. I guess we could see what happens, but it's still rolling, so we'll see.
Okay, if we get cut off, you'll know what happened.
Yeah, you'll see bars and tone. The first question was favorite film photograph from my childhood. That's a tough one. I don't. There's not one that's immediately coming to mind that's like that I remember well from my childhood. I probably could look through some and be like, oh, of course. Like we had, all the pictures we had of me and my family and stuff were all on film, and the ones we had hanging on the walls and stuff, of course. But there is one that I was given this bag of like slides. So it's like not a negative because it's been processed in a way where you can put it in one of those slide projectors. Yeah. And so it's a positive. And from my family, from my mom's parents specifically, I found this very, in that, there were a lot of things that weren't that notable and weren't like gems. But there's one specific one, a picture of my grandparents super young. And so I scanned that one. This was probably about 5 or 6 years ago that I got that. And no one else in my family has any like equipment for this. Not that you would need it. You could find somebody else who has it, or there's probably services online or something you could send it off to. But I scanned those, and it was amazing getting this picture of my grandparents so young. It is like a really good picture, and it is eerie seeing them look so, I don't know, so relatable in their age. Like they're in their like late 20s, early 30s in the picture. Yeah. And it's like, what?
Like, that's how old I am.
Yeah.
Yeah.
So I like that picture a lot for that reason, but it's not like one that I have fond memories of seeing. Yeah. You know what I mean? But
I think that fits the brief.
Yeah. How about you?
I have two that I really love, and one is with me and my cousin. One of my favorite cousins growing up, and we both lost our 2 front teeth at the same time. And so we have our arms around, like, on each other's shoulders and both smiling with our 2 front teeth missing. And I love that picture so much. It's genuinely, like, I have pictures of it on my phone or whatever, but I keep it in my fireproof safe because I'm like, I love this picture. Yeah. And then there's also the other one that's in my fireproof safe is a picture of me and my mom at Christmas, and all my cousins were like playing with their Christmas toys, and I was just on the couch with my mom under a blankie. And I was like, it's so sweet because my mom, has passed away, and so it's like, just like a nice picture of me and her, but it's like a picture of us cuddling, like, which you don't get that very often, but I love to cuddle, and I love just like being held in human contact. But also, I'm like, I still sometimes get overwhelmed at events and just want to go be by my safe person and have them put their arm around me.
Yeah,
And like,
yeah.
so I'm like, oh, that part of me is displayed that I feel like doesn't often get displayed, you know? And so it's just like, and back then you don't get pictures of, now I feel like we have lots of pictures of like mom holding their kids.
Yeah.
But back then it was like pictures were for events, you know? And so like having a picture of that like very normal moment with me and my mom is really sweet. And
Yeah.
our friend Nicole took that print and like took the photo and had somebody draw like render an art image of it. So I have like a abstract sort of drawing of that.
That's cool.
In my room.
That's really cool. Yeah.
All right.
I love that.
And what about your film journey? Are you still a film guy?
I am. I not super frequently, but I actually did take my film camera on a trip recently. And my like film camera, not instant film, my Pentax camera. And so like what we just talked about, except in color, not black and white. And that's really fun. I was given that camera by one of my coworkers back when I worked for the humanitarian organization. He had some old Pentax cameras, and he had one that was just in his closet for like a long time. I think it was his dad's actually. He had one and his dad had one, but his dad's one is missing like the hot shoe attachment thing on the top.
What does that do?
Which we don't really need. You could add a flash up there and stuff.
Oh, okay.
And connect it. So that part wouldn't work, but I probably wouldn't have used that anyway.
Yeah.
And I love that it was just given to me by somebody. And Pentax is a cool brand and stuff from back in the day. And so I was given that probably in like 2015, 2016. I had done some instant film stuff before that. Like I have an old Polaroid camera. And then, of course, we have one or two Instax cameras, but I have like an old actual Polaroid one from I want to say it's an 1980 something model. But
that's crazy.
Those are really fun, but I didn't get into like an actual film camera that you wind and do all of that stuff until I was given that one, and that's been really fun. Some of my favorite pictures are on that one, and it's really fun to scan those and stuff. You can get them developed somewhere else, then scan them yourself, and that's what I kind of how I got into that. It's very hard though, and so there are times where I'm just like, I'll just have wherever I'm sending it to develop these photos, I'll have them just scan them.
Yeah, and
maybe I'll do it myself later as well, and have like slightly higher resolution ones or something. But what's crazy is that you're adding a whole other factor of, okay, this has already been developed and it's a negative. Now I'm scanning it, and how good of a job is the scanner doing seeing stuff? And what happens a lot is that people develop these profiles for scanners so that it will interpret colors in a certain way that is favorable, not like trying to edit it.
Yeah.
But you honestly can't just leave it as it is.
Yeah.
It looks a little weird. It's like that's not how it was.
Yeah.
And I'm betting the film is correct. It's the scanner that's adding a layer of difficulty here. You know? But that's been fun. I haven't done scanning in a long time, but also haven't been shooting near as much, so I haven't really had much to scan. But that was one of those hobbies that both the taking photos on a film camera and the scanning of them that went somewhat dormant after having kids.
Yeah.
So
I feel like I could see you getting into developing film yourself.
Yeah.
I think that's the kind of thing that the type of hobby that you appreciate, where it's like, this is productive. I'm creating something. It's a skill that I'm developing. It's useful. You could turn it into a side business. Yeah,
that's true. That would be pretty fun. And our friends Matt and Danielle Clark, the house they have in Plano, it has this weird room in their garage that they obviously have no need for, and they're kind of annoyed by it. But the person who lived there before had turned like a quarter of their garage into a dark room.
That is so
for
cool.
developing. And it's one of the things where I'm like, man, that's what a cool hobby. But also, you must have been really into it to like convert part of your...
Yeah, you didn't just do it in a closet or something. Or
it's
your
like
laundry room.
You must have been doing this a lot for, maybe it was even their job or something. I don't know.
Yeah,
but
that's cool.
That would be cool. I wonder... Also, I bet at this stage with a lot of film photography stuff being so expensive, I'm sure you could crunch the numbers on buying some, jugs of the right, steps of chemicals to the baths you have to do in the right order or whatever. And it could be, if I do this enough and I'm not wasting a ton of the different chemicals I need to use each time, then it probably could get economical to develop it yourself.
Yeah.
But I also could see it being a money pit.
Yeah. Yeah.
It's like, man, I had to order, this many gallons of this stuff and it's cheaper to do this. So I ended up buying $300 worth of it. Kind of the way that our coffee stuff goes, where it's like now we're buying these high quantities. Yeah. We're actually going through it, which is good.
Yeah.
But I could see it becoming a problem. Yeah.
That's funny. All right. Well, that's all I have for you. Thanks for coming and learning about film. And we'll be back for part 2 in just a few weeks.
Well, thanks for teaching us. And you know what? Just as a cool kind of bonus incentive sort of thing, I'll post some of my favorite film photographs, maybe on Patreon.
Yeah, that's a great idea.
Just kind of a cool, some of them I would probably feel fine posting publicly, but a couple of them I'm like, I don't think I would. My grandparents one, that one seems a little weird to just put out there, but I don't know why, but it does. So
it feels intimate.
Yes. Yeah, definitely.
Yeah.
But yeah, I'll post some of those. That'll be fun. And thanks for teaching us. And for, me and others asking this question, Brian, thank y'all for your questions and your ideas for episodes. We love those. If you have any follow-ups for this, we love that too. So send those to us on our website at chemforyourlife.com. That's chemforyourlife.com to share your thoughts, ideas, questions with us. If you'd like to help us keep our show going and contribute to cover the cost of making it, you can join our super cool Chem community of patrons on patreon.com/chemforyourlife. That's patreon.com/chemforyourlife to join our super cool Chem community. Just like Justine, yes. I was like, why can I not? We just said her name moments ago. I guess it was 50 minutes ago.
That's
just
true.
Like Justine did. You get an ad-free feed of the show. You get bonus episode every month. Blah blah blah. Ways for us to say thank you for keeping the show going, and we could not do this without you. But if you're not able to do that, you can still help us by subscribing on your favorite podcast app, rating, writing a review on Apple Podcasts and Spotify, subscribing on YouTube, and something we fail to mention a lot, you can also support the show just by buying some merch on our website at chemforyourlife.com/store. We've got some cool stuff on there. We will try to get better at mentioning this because we haven't plugged it in a while. But that's a great way to one-time, support the show and represent, and have other people have the chance of experiencing and learning about the show and chemistry because they see it on your cool shirt, or your cool hat. So, those things all help us to share chemistry with even more people.
And I'll send some pictures to the Patreon as well. The one of me and my cousin, and the one of me and my mom, and the really beautiful print that she had done. That was a really nice gift, so that you too can experience not just Jam's life in film, but also mine. They're not going to be artistic film though. I mean, definitely wearing a Barney blanket in that one. Okay. But yes, we want to thank all of our subscribers on Patreon for supporting the podcast. And we want to thank every single one of them. Starting with Justine, welcome to the fold. We're very excited to have you. Hope you like the pictures we're going to post. And we also like to thank Chris and Claire, Hunter, Katrina, Lynn, Scott, Steven, Timothy, Vince, who just upgraded to the H Bonders. We better see it at Coffee Hour Vince, Ash, Brian, Chelsea, Doreen, Elizabeth, Emily, Heather, John, Jesse, Latila, Rachel, Autoclave, Avishai, Chelsea, Sierra, Cullen, Emerson, Erica, Jacob, Jeanette, Julie, Justine, again. Thank you all so much. Did I get everybody? Oh, Christina, Suzanne, and Venus. Sorry, Justine distracted me. So thank you all so much for everything you do to make this podcast happen and for wanting to share chemistry with even more people. And this episode of Chemistry for Your Life was created by me, Melissa Collini, and him, Jam Robinson. And if you'd like to learn more about today's episode, you can check out our show notes.
But also, if you'd like to learn more about today's chemistry lesson, you can check out our show notes.
I know, I stole it from you.
You did it last time too, and I was like, what am I supposed to say?
Because it feels like it flows better if I'm like, this episode was created by. Okay, yeah, you can have it back.
No, I'm just kidding. No, it doesn't matter. It is funny how we like put that at the very, very end. It's like someone has listened to all this other stuff and now we're telling them that their sources. We probably could move that earlier if we wanted.
Yeah, we probably could.
But old habits die hard. Like, what if we really messed up the flow of any other part of the stuff that I say? I'd have to like.
It would totally trip you up.
Yeah, I'd have to go back.
Yeah, he doesn't read that. He just knows what he wants to say every time.
Well, it helps that we've done it 200 times. Not even though we changed it,
Probably more, honestly.
Yeah. Yay chemistry.
Yay chemistry. Yay photography. That was so